Finished? Thanks for coming. This feels like it's a conference heavily weighted to change management and agile, hand-wavy, managing type stuff. So we thought we'd inject a bit of actual programming. Because, let's face it, you can't be agile unless you're writing habitable code, unless you're keeping your code clean and lean. And it's not always obvious how to do that. So we're going to do a bit of live coding, or Jim's going to do a bit of live coding, should I say. So I'm Kevin. I'm an XP coach. Been doing XP since 1999, and before that I was doing non-XP. And this is Jim.
I've been working with software in a few different domains over the last 7 or 8 years. Now working for Allegro Networks, doing network automation with lots of refactoring.
So what we're going to do is, who here actually writes code on a day-to-day basis? Okay, good. That's pretty much everybody, so that's good. You'll all probably have heard of Pragmatic Dave's back to the checkout kata. It's used in interviews all across the Northwest. I have heard of people turning up for interviews and they say, right, we're going to do the checkout kata, and they do it in exactly the way that we've done at XP Manchester or whatever. And at the end they can't answer questions on it because all they've done is watch other people do it. It's a bit weird. So we're going to do that, but we're going to do it in a highly reflective way, so that we can talk about the refactoring part of TDD.
Okay, so just before I start, can everyone hear me okay at the back? I know I've got quite a quiet voice normally, so...
Hands up if you can't hear Jim.
Okay, so let's dive into our code straight away. So, again, can everyone read this okay from the back? Yep, good. So, those who know the checkout kata will probably recognize this test. So, we have a checkout, we scan something, and we check that it's 50. So, I'm just going to give that a better name. I'm just going to check. So, call it test scanning one item.
So the assumption with this test at the moment is whatever we scan, the price of it is going to be 50. Everything has the same price.
So I'm going to go ahead and make our checkout class.
So this is the red part of the red-green refactor, right? We're writing a test to demonstrate the business logic that we want to code up.
Okay.
And it's currently red because it doesn't compile.
So I'm just going to go through and get it to compile. So we had a scan method. And a current balance method. And we'll get it to return an int because at the moment we've got that as 50. We'll just set that to 0 for now.
Everybody comfortable with Java? Feels like a kind of lowest common denominator.
And I'm not sure if everyone can read that at the bottom, but I'm sure you can see the red bar there at least. So we're saying it was expecting 50 but was 0.
So that's the red part, right? We're red now. So we're off and we're on the TDD cycle.
Okay, so now we're going to do the simplest thing we can to make this pass. So the simplest thing we can do right now is just get our current balance method to return 50. So if we run our tests now, then we're green.
So that's red, green, and the next thing we're told to do is refactor. And has anybody not read Kent Beck's TED by example? Okay, so there's only a small number of you haven't read it. It's a brilliant introduction to TED. It set the scene for what was to come. But I've got a massive problem with it and books of that ilk, which is that Kent and the other experts tend to say, okay, so we're going to refactor now. Look, there's some duplication here. Wham bam, magic stuff, and it's gone. And sometimes I can't even see that there's duplication there. I don't necessarily agree that that's what should be done next. Refactoring to these guys is based on years of instinct and insight, and they kind of forget that the rest of us haven't got all of that, haven't been through that, through their experiences, and they just say, hand wavy, some duplication here, and sometimes you can see it, sometimes you can't. Sometimes you agree that, yes, that's the most important thing to fix. But not always, and it's not always obvious. The refactor step feels like it's very arty, very sort of subjective. So we want to talk about a kind of an approach to tackling that. So Kent and his pals talk about code smells, and they've all got funky names. And it's not always obvious what those names mean. So, what's the difference between feature envy and inappropriate intimacy? Genuine code smells, genuine names for code smells. How does it help? What does it mean? It's kind of subjective. They were given funky names so that you would remember them. And most people remember the names, but actually what those names are intended to mean, an awful lot of people seem to forget. So there's an alternative, which is connaissance, which was first described about 20 years ago by Myla Page Jones in a couple of really impenetrable computer science books. But connaissance basically says coupling is what kills you. When the experts in TED do their hand wavy stuff and talk about duplication and code smells and stuff, what they're talking about is coupling. That they want us to decouple our code. Refactoring is about decoupling things. And if we can decouple things, then we can change one of them without needing to change the other. So coupling is what slows us down. Duplication is another term for coupling, but it's kind of too wishy-washy. So Page Jones tried to produce a kind of algebra of coupling, and this is it. So there are 9 kinds of connaissance, and they go from not very serious to extremely serious. And what we're going to demonstrate this afternoon is that by recognizing which kinds of connaissance we've got in the code, that tells us what sequence to do the refactorings in and what kind of refactoring to do in order to decouple the code, remove duplication. So we're going to use connaissance as our signpost to help us do the refactoring step, to help in some ways take away some of that hand-wavy, Kent Becky, this is duplication, we'll just magic it away sort of stuff. So I'll do a quick run through of the 9 kinds of connaissance. I don't expect much of it to stick. This is just a very quick overview. During the live coding, we're going to visit 7 of them in detail. So, first of all, connaissance of name. that means that two areas of your code are coupled because they both know the name of something. So for example, in order to call a method, you have to know its name. If the name of the method changes, the code that's calling it won't be able to. If the code that's calling it changes the name of the method it's calling, then it won't call the method it was calling. Yeah? So that's coupling between two things. They both have to agree that that's the name of that they're both going to use. Variables, class names, constant names. Yeah, it's kind of inescapable. We have to know the names of things in order to be able to talk to them. But it's worth knowing that we're putting that kind of coupling in the code. So connaissance of name is all pervasive. It's not particularly serious, but it's worth remembering that it is coupling. Yeah. So the next kind is connaissance of type. Two pieces of code are coupled because they both have to agree on the type of something. So when I'm calling a method, I have to know what the return type is. When I'm instantiating an object, I have to know what class I want to instantiate. Two parts of the code are therefore coupled because they have to agree on a type. Again, it's all pervasive. If we didn't have connaissance of type, nothing would ever get done. It's more visible in languages like Java than it is in dynamically typed languages like Ruby. But even in those languages, it's there all the time. It's just that it's harder to see. It's slightly worse than connaissance of name, but it's there all the time. So we have to recognize that we've got that kind of coupling. The next more serious is connaissance of meaning, where two chunks of code have to agree on what something means. So for example, if you've got a string, it might be that two objects or two functions in the code both have to agree that that string contains a postcode. And they both have to agree on what the representation of postcode is in that string. So they're both interpreting that string, and they have to interpret it in the same way. So for example, if you've got a function that returns null as a special case when something goes wrong, that function and all of its clients have to agree what null means. They have to agree that null means I couldn't do what you asked me to do, or whatever it was. So they're agreeing on the meaning of that special case. This is worse than either of the other two because it's harder to spot, it's harder to work around, and it causes all sorts of subtle bugs. Going up the scale, we've got connaissance of algorithm. So this is where you've got two pieces of code that have to agree on how something is done. So for example, you might write a test for a fingerprinting algorithm, and the test has to use the same hashing algorithm in order to pass. So you've got the same algorithm implemented in two places. And if either of them changes, something will break. So remember, this is about coupling. There's two or more places in the code that are joined together by some assumption. So going up the scale again, connaissance of position is where you've got a whole bunch of things, and you have to know by magic which of them means which. So maybe you've got a message buffer that's you have to know that the first byte is the message length, the second byte is the message type, and the third byte is the number of fields in the message or something like that. And both the sender and the receiver of that message have to agree on all of that and agree where each of the bits of that message are. So connaissance of position is really hard to detect, causes all sorts of interesting bugs. And basically you're saying we all have to agree on this being the correct agreed sequence of things. So now we're into things. So those first five, you can detect them by static analysis of code. You can detect them all by just reading code. The remaining four, which are all worse, you can really only detect at runtime. So connaissance of execution order. For example, you've got an email system, and you have to set the recipient before you can send the email. So the client is coupled to the way the API has been designed. You're forcing the client to do things in a certain order, and everyone has to agree on that in order for anything to work. Yeah. Connaissance of timing, where something only works if the timing is right. Classic examples of this are Selenium tests. You've got UI tests that test your application through the browser, and they only work because there's a sleep of 2 seconds in at this point. Connaissance of value is, as it says on the tin, two areas of code only work together because they both agree on the value of something. A hard-coded value that they both know. And finally, connaissance of identity, which is that actually the code only works if you're talking to actually that actual thing. Singleton is a classic example of that. Unless you're talking to that instance of the thing, it's not going to work. Two instances of a singleton, both with different state. Whichever one you talk to, you get different view of the world. So, connaissance of identity basically says global variables are another one. Your code is coupled to specific instances of things. So those are the 9 kinds of connaissance. What we're going to do is, sorry.
So the example that you gave for the connaissance of value was a static variable, but this is something that can be detected by static analysis of the code, right?
Connaissance of value, no, not static values, just agreeing on any magic number or any magic value.
So this magic number can be like something that is read during execution time?
Yes, yeah. So what we're going to do is we're going to run through the checkout kata, but paying close attention to which kinds of connaissance we've got. And what we're going to do is we're going to fix things in order of severity. So whenever we've got to the green step, what we do is, what kinds of connaissance do we have? Which one is the worst? Okay, well, we'll fix that next. We're going to use connaissance as our signpost to tell us what to do. So we've written that first test. We've made it pass. And the question is, what kind of connaissance do we have in the code? So we've clearly got connaissance of type and connaissance of name, otherwise the thing wouldn't compile. We're always going to have those. They're always there, and that's kind of fine.
We've also got connaissance and value here as well. So you were asking before about what that could mean. So here we've got a 50 in our checkout tests and a 50 in our checkout. So I'm going to represent this in here. So here we can see we've got connascence of value, which is a worse sort of connascence, and then also connascence of execution order, because right now our scan method doesn't do anything. So
you can scan as many things as you like and you'll still only get 50 back as the total. So the client only works because it knows that. The client only works because it knows that the total is returned here and the scan method does nothing. Does that make sense? So the checkout has implemented an algorithm which is do nothing, and the test only passes because the test knows that as well.
Could you get rid of that just by deleting the scan method, theoretically?
But then the test wouldn't be expressing the business rule that we want. So the connascenceometer says we've got connascence of value, which is level 8, so we need to fix that first.
So the simplest way for us to do this would be for us to pass in our 50 into somewhere in our tests. So we could either pass that in through our current balance method, which I don't think really makes any sense, our scan method, which makes slightly more sense, but let's go with in our constructor.
So what we're doing here is we're invoking the dependency inversion principle from solid, which says don't depend on details, depend on abstractions. So right now the test depends on a detail inside the checkout. And those of you who know Joe Rainsberger's work, he always says to invert dependencies, pass details up the call stack, move details up into the caller. So we're taking a detail from the checkout and we're moving it up into the test so that the test passes it back in.
So I've just passed this in as a constructor parameter, added it as a field, and now returning it in our current balance method. So if we run our tests now to make sure we've not made any mistakes, we're still green. So we've got rid of our connascence of value.
So what we've done is we've taken the two ends of this connection and we've moved this end into here. Yeah, so it's like physical coupling. There's a piece of string joining these two things, and we've taken this one and moved it over here, so the piece of string is a lot shorter. Right now it's still there in the test. It's just that we've shrunk it, which weakens it. Yeah. So we've now freed this from the coupling. It doesn't have connascence of value with anything anymore. But inside the test, we've got a little bit of connascence of value because we've moved this end into here.
Duplication.
Duplication, yeah.
So we've still got that in here, and now we can weaken this even more by refactoring this into a local variable, which just gives us connascence of name. So if we refactor this into a variable called item price, and make sure we use item price down here. And when we run our tests, we're still green.
So the TDD books just wave their hands and say, oh, 50-50, we need to fix that. Connascence says, that's connascence of value, that's level 8 on the scale, that's serious, you need to sort it out before you do anything else, and here's how you do it. Anthony, yes? Was that a question?
Pulling out the definition of what the numerals mean into the text.
Yeah.
And it just felt a bit wrong because why are we telling you what the numerals are? You should know, you're the implementation. But
so what you end up with is a general purpose algorithm that you feed with specific data. Yeah.
It just felt weird, but it's right because that's the algorithms.
Yes. So this, you're right. This is all the Ken Beck hand wavy stuff. You've got duplication. We'll fix it. This is telling us how to fix it, why we're fixing it, what the outcomes
So now we've got rid of our connasance of value, but we've introduced, well, in fact not introduced, but highlighted connasance of meaning here in our ints. However, as connasance of execution order.
So all of these ints actually represent monetary values. And because of that, we've got connasance of meaning. So the test and the checkout both have to agree that we're representing money using ints. And it wasn't obvious before. You couldn't really see that before because there were no ints in the method signatures, or not very many. But now it's much worse.
However, our connassanceometer at the bottom here is telling us that connasance of execution order is more serious than that. So for now, we're going to ignore connasance of meaning and come back to that in a bit. So we don't have a reason in our tests to implement anything in our scan method right now. So we're going to introduce a new test. So that's a checkout with an empty basket. So if I just quickly copy this into a new test.
So whenever I've got connasance of execution order, the first thing I do is write another test that fails because I'm calling things in the wrong order. So I'm making that particular kind of coupling visible. I'm writing a test that deliberately does things in the wrong order, force it to fail, and by making it pass, I'm gonna fix that connasance. So that's my answer to connasance of execution order all the time.
So if we run our tests now, we can see we've got failure. So our simplest way of fixing this is to introduce the concept of a balance for the checkout. So if we say for each time the item is scanned, then we increase it by the item price. And then in our current balance method, we just return the balance. And then we're back to green. So now what forms of connasance do we have? So we've still got our connasance of meaning, but we've also got connasance of algorithm now because we need to know how to create our new checkout and give it an item price in both of our two tests. So again, our connassanceometer is telling us that connasance of algorithm is worse out of the two of these.
Arguably, it's not because it's within the same class, so the coupling is contained. Whereas the connasance of meaning, there's more of it, and it's spread more throughout the system. So this is where we make a trade-off and say, for the purposes of this, we're gonna fix connasance of algorithm first. But you would probably, in real life, you'd probably fix connasance of meaning first because it's more diverse. It's affecting a broader spread of the code.
So the simplest way we can fix this is to refactor this into a setup or a before block for n unit. So if we start off by doing this by introducing fields for both the item price and the checkout, and then afraid I can't quite remember the keyboard shortcut for extract method. There we go. And then add before to it. So this will be run before every test. So if we run that now, then we should still be green. So we just need to remove this from our test. And to make this a bit clearer, I'm just going to move this above our other test. Okay, so Now we've fixed our connaissance of algorithm. We've still got connaissance of meaning.
So we had the same algorithm in two places. We just extracted something so that it was only one place. Simples.
So our connaissance of meaning. So that's where we've got a monetary value being represented by 50. Now, I worked on a software system once where we represented money by floats, ints, and doubles. So you can imagine, like, doesn't it mean 50 pence, or does it mean 50 pounds, or something else? So
there was a spacecraft blew up on the launch pad, wasn't there? Because one team had worked in inches, another team had worked in centimetres, and they'd never actually integration tested the stuff. $5 billion of integration tests on the launch pad with live rocket fuel. So that's connaissance of meaning. I also worked on a financial app where we had money represented by all sorts of things. And when we finally bit the bullet and said, okay, what we're going to do now is we're going to have a money class, we had to change 7,000 places in the code. Connaissance of meaning is a really, probably the most interesting. I mean, it's in the Ken Beck world, it's primitive obsession, and it gets everywhere. You think, I mean, we've only got a few lines of code here, but the number of places where that int crops up is alarming already. And connaissance allows us to see it, allows us to, gives us a tool for saying, look, we've got this, we need to sort it out. If we don't sort it out now, it'll kill us later.
So to get rid of this, I'm going to introduce a money class. Now, for convenience, I've actually got one I prepared earlier.
Hand waving, hand waving.
So
the reason we use a factory method like that is, again, to document the assumption we're making about what the meaning of that magic value is. You might have a from pounds method and all sorts of other factory methods. You're documenting the special meaning of that point.
So, just going through updating all of our references to item price to use our money class instead, which means I'm also having to do this for balance, which I need to now initialize to 0 and change the return type of our current balance. So this still won't quite work. We need to change our empty checkout test to also use it. So if we run that now, back to our green bar, and we've removed the connaissance of meaning.
So now the checkout and its tests are communicating using an object that we've defined. So we've got rid of the primitive obsession. In the API of checkout, there's no mention now of any type that we haven't defined ourselves.
Sorry, can I ask, with connaissance of algorithm, do you think that certain methods can be used to hide the actual setup pain in production?
Yes.
I tend to shy away from using them.
I know what you mean. This is a tutorial, so we're just kind of using it as an example of that. I quite like to organise my tests around context. So each test class will create a context, inject some sort of stimulus, and then test for the expected outcomes of that. So you could see that in this way. If that makes sense.
Yeah.
But yeah, we wanted to shoehorn connaissance of algorithm in here somewhere, so that was a good place to do it.
So got rid of our connaissance of meaning. And so now we're just left with connaissance of type and connaissance of name, which we've kind of decided are kind of necessary. Otherwise, we've just got things not interacting with other things.
So it's really important observation to hammer home here is that the public API of the checkout doesn't mention any classes or any types. The only types it mentions are ones that we've defined ourselves. So we're in control of the meaning of everything going across that interface.
So now we've got rid of most of these types of connaissance. Yes, this is probably a good time for us to add another test. So our next test is going to be that different items have different prices.
So connaissance there has helped us know when to stop. Yeah, there's a lot less hand waving. We can just say, we got rid of all the serious kinds of coupling, so now it's time to move on.
Could you just go back a little bit for me? So I'm slightly confused about what happened to the connaissance of execution order. Where's it gone? I think perhaps I misunderstood what it was that it represented, the connaissance of execution order.
Okay.
I don't see how that's vanished.
So here, scan actually did nothing, and yet we got 50 out of the current balance. We could have scanned 2 items, 3 items, 12 items, and still we would only ever get 50 out of the current balance. So there's no relationship between the number of items we're scanning and the price we have to pay.
And importantly, our tests know that and understand that, and that's where the connaissance comes in. So our tests know that, or knew that, scanning this however many times wouldn't change the result.
So we got rid of it by redesigning the algorithm so that scan did do something, so that every time you scanned an item, it incremented the balance. And we test drove that.
Does that make sense?
So current balance was effectively relying on the facts that the execution order had been that there had been precisely one scan before it.
Yes.
Yeah.
And that's the only way the test worked. So all of these things were coupled together because of that.
So we wrote another test to expose that flaw,
Yeah.
which caused us to solve the problem.
Yeah.
And let's get rid of the
Yeah. So the failing test causes to fix that, and we just fixed it by, doing proper programming. There was no refactoring magic there. Makes sense? Cool.
Okay, so if we add our next test in,
Can you scroll up a bit? Or can you move the new test up?
Kevin, what would have been the change if you'd done this next test that you're going to do instead of doing the empty test? Would you have got a different outcome with that? Because you specifically chose to do the test empty basket, for example, rather than highlight that with test 2 items, for example.
Yeah. So instead of test empty basket, we could have scanned
2
twice.
items,
Yeah, and it would have exposed the bug just the same. Yeah.
I'm just wondering if there would have been a different design decision when we'd done that, or whether I don't know.
Well, that's an exercise for you to try at home and report back using the Agile Mank hashtag. We deliberately sprinkled this with exercises for you to do.
so
I think it gets you to the same point. Or it did when I tried it. But then I knew where I was heading.
So we're scanning 2 items now. So we call the first item A, the second item B, and we'll also need to update that in a minute.
So the intention of this test now is that we can have different items with different prices. Yeah, we're beyond just assuming that they all have the same price.
So if we say our B item costs 30p, so A plus B will be 80. So before we can run our tests, we've actually broken this test because we're not passing anything in here. So if we just add in, let's say our first item was an A, which matches our item price. So we run our tests, we get our failing test. Now the simplest way we can get this passing is for us to check whether it's an A that we're passing into scan before we increase the balance. So if we say if the SKU is A, then increase the balance by item price. Otherwise, increase it by 30 pence, which was our price.
So this is a critical part of the red-green refactor cycle. The green part, you really have to switch your brain off and just type. When you write the test, when you write the failing test, you're designing the expected behaviour of the outside of your black box. So you're kind of being a business analyst. When you write when you make it green, you just want to switch off all the thinking parts of your brain and just make it pass. Just drive a bulldozer through the code. Just get it to green as fast as you possibly can, and it doesn't matter what damage you do in achieving that. As long as you get to the green bar as quickly as you can, that's the next safe point. And it's at that point that we can look at the kinesiosometer and say, what damage have we done? What do we need to fix now? And we're safe in fixing it because we're green, because we've got tests holding us up.
So I think you described this quite well the other day when you said when you're writing your tests, you're designing the outside of your class. Then once you're green and you're refactoring, you're designing the inside of your class, which I thought was quite a nice way of putting it. So now that we've got our test passing with our check in here, we can have a look and see what types of kinesins we've got. So we've got kinesins of value because we've got an A in both, and also kinesins of value because we've got 30 pence in both. We've also got kinesins of algorithm here because we know how we increment our balance in both places. So, and kinesins of meaning, which I missed there, which was for our SKU. So both the tests and the code both understand that this string represents an SKU. And for those not familiar with the checkout kata, SKU is stock keeping unit, like a barcode.
Does that cover also understanding that a SKU of A is worth 30? There's a couple
yes.
of terms.
Yes, I suppose there would be to some extent. Well, not necessarily actually, because it would just be that the price of an A and the price of a B would be 30, not necessarily the relationship between the two at this point. So our kinesiosometer tells us that kinesins of value is the worst type of kinesins that we have at the moment. So we've got two here, but I'm going to start with the kinesins of value in the 30 pence. So again, as we did earlier, I'm just going to push this up the stack into here. So I've got we add this in our constructor, change our constructor to reflect that. Assign this to a field, and then again, rather than 30 pence here, we can just use price of B. So just going to run my tests to make sure I've not made any mistakes. Okay, that's working so far.
So again, we've taken the hard-coded value from one side and we've moved it into the other side to inject it back in. So this is taking that piece of string and moving the ends of it closer together. And one outcome of that is that the checkout becomes generalized. It's more general than it was before.
So before we move on, just for clarity, I'm going to update these names. So we've got price of A rather than item price. Okay. So we've also still got connaissance of value in our test here. So even though we've made it weaker, we could make this even weaker still by changing it to connaissance of name. So I'm just going to extract this to a local variable here, call it price of B, and then change this to a local field. Okay, so now if we start using that in here, then we've reduced that connaissance. Now we've still got item price here, so I'm just going to quickly rename this as well to price of A.
Arguably, there's some kind of connaissance there between what the variable was called and what it means. So it was called item price, but it meant price of A. There's something going on there. I haven't quite figured out what, but we know we need to change it.
So back in our diagram here, we've got rid of our connaissance of value, but we've introduced connaissance of position, in fact. So connaissance of position is where in our case, both the test and the code rely on the order of the constructor arguments. So we have two money objects coming in here. So it'd be quite easy for us to get those the wrong way around. And
so the checkout and the test both have to agree which one means B and which one means A. And it'd be really easy to call that constructor with them in the wrong way around, and that will break the test. So that's why it's level 5 on the scale. It's worse than some of the others because you really have to detect it using tests. If you haven't got tests, it can kill you.
So before we...
You can quote me on that.
I'm quoting them.
So before we move on to fixing that, we've still got connaissance of value with the A in both tests. So, like we've done with everything else, we'll pass A into our constructor. So again, we're moving this up the stack. So if we change our constructor to take item A, assign that to a parameter, and then start using that in our scan method. Now, when we run our tests, we're still green. However, not got rid of it
So
yet.
again, we've taken the two hard-coded values in different classes. We've moved them both so that they're in the same class. So we've taken that piece of string and we've moved the ends together. And now that we've done that, we can eliminate it completely.
So we can do that by just extract this to a local variable and then a field. then we can use it down here and also in our original test.
Now notice that we don't have the same problem with B, because that's the only place in the code it's mentioned. We can change that to Z and everything will still pass. So it's not just about having magic values in, it's about having multiple places in the code that interpret those magic values and depend upon them.
So before we go on, I'm just going to quickly tidy this up slightly by changing our fields to be initialized up here, as that's the only place they're used. Okay, so run my tests to verify that. We're still good. Okay, so we've removed our connaissance of value there, leaving us with our connaissance of position. So
we've still got all the other kinds of connaissance there. We'll get around to those eventually. But the connaissance ometer is telling us this is the order we should fix things in.
So the connaissance of position is that we're relying on both knowing which order that they're passed. So a simpler way for us to get rid of this connaissance is for us to convert this to connaissance of name. So if we have some way of mapping an item to the price of an item, then that will get rid of it.
So if we just flip back to the checkout, inside the checkout constructor here, it has no way of knowing what the caller intended here. It's saying, I want you to pass price of A first and price of B second, but it's got no way of actually verifying that. So, classic fix for this, if you've got a language like Ruby where you can have named parameters, you could actually insist that the caller use named parameters here. What we want to do is associate names with these things so that we know which is which, so that the caller has to use our names. We're in Java, so we haven't got named parameters. So the next best thing is actually to pass something into the checkout that does that for us. Associates the SKU with its price. The obvious thing for that is a dictionary or a map. So we're going to fix this by passing in a map that says item A has this price, item B has this price. That makes sense? Mm-hmm. So those two parameters to the constructor, because they've got the same type, the compiler can't help us. We can only know at runtime with tests whether we're calling it correctly. So if instead we actually create a data structure that maps those names to their meanings, then fewer opportunities to get it wrong. We're reducing the connaissance of position to connaissance of name.
And so, as we've done before, we can pass a map into our constructor of the checkout. So I've got a simple map set up between string, which is going to be our SKU, and money, and I've just populated that with our data. So
to import hash map.
Oh yes, thank you. So again, if we pass that into our constructor and update our constructor to match that.
Anybody here not read Martin Fowler's refactoring book? You've not read anything, have you? The classic structure of most of his refactoring moves is create something new, migrate all the callers of the old thing so that they use the new thing, then you can delete the old thing. What we're doing here is we're passing in something new, then we're going to make the checkout use the new thing bit by bit, and then at some point the old stuff won't be used anymore, so we can get rid. Yes?
Yeah, I was going to ask about that. When you introduced the SKU in scan method,
Yeah.
I thought we might have introduced a new scan overload with the string, but we get to the same result anyway.
Yeah. That would have, that adds kind of cognitive drag. Two scan methods doing different things.
But then you wouldn't have had to have the tests.
Yeah. They stopped compiling for about 5 seconds, so yeah, in a bigger system, we'd have gone more carefully.
So I've just changed for when the SKU is A to increase the balance by the price in our prices map.
So the test should still pass at that point.
Yes. So if we run those, we're still green.
So we converted one use of this stuff so that it uses the new stuff instead. So we're gradually migrating code over to use the new thing.
And then for the
In fact, we could do the same here. We could do prices.get SKU here because price of B we're going to get from the price list as well. So the test should still pass at this point. Yeah.
So we're still green.
So now we've got an if that we don't need.
So I guess we could argue that this is connaissance of algorithm, but we'll just get rid of it for now. And our test should still pass. Great. So we've got rid of our connaissance of position.
So we've got some stuff we can delete from the checkout.
We do. So we've got our prices and our item here, which aren't used anymore. So we can safely get rid of those. We just run our tests to make sure. And the fields as well.
Sorry, that's me.
And then we can do the same for our method signature. So if we remove the item, the price of A and the price of B, that leaves us with quite a simple looking checkout now. And if we just run our tests again,
So we're tending to find that every time we fix some connaissance, our code generalizes. Because we're taking something that it was coupled to and moving it out. And inch by inch, we're building a general purpose checkout class, but we're doing it in a very controlled manner.
So another common thing is we've been moving between types of connaissance. So we got rid of connaissance of position there, but we have introduced connaissance of value, which we knew didn't feel right earlier on when we had our B here and item A. So now we've got the opportunity to get rid of that. So
the two ends of this one are in the same class, so it's not as strong as connaissance with the checkout itself, but it's still connaissance of value, so it's high up the list. So let's get rid of it now. So connaissance isn't something you can get rid of. All you can really do is change its nature, convert it from one type to another. And what we want to be doing is converting it from strong, serious, nasty types to the weaker, less nasty types. And the whole thing about the connaissanceometer is it tells us which direction to go. So I've seen places where refactoring goes around in circles. You know, we'll fix this feature envy, so we'll move that into there, and now it's exposing something to over here, so we'll move that over to there. And now we've got a huge class, so we need to move these things out. But now we've got feature envy again, so we need to move it back in. And you just following the code smelly type refactoring often just takes you around in circles or never ends. With connascence, you're saying this is coupled to this for this reason. And what we have to do is move that over there, or move that over there, or move them both over to here. And it tells you when to stop.
So at this point, we're left with just connascence of meaning for our string, which is our SKU in our scan method. So we know that what we're passing in here and receiving in here represents an SKU. And our connascence of meaning in the map, given that we know that it's a map between the items or the item SKUs and their prices.
So another way to think about that is that the public interface of the checkout is expressed in terms of types we didn't define. And because of that, the checkout and its clients have to agree on what these things mean. We're getting a map of string to money. It could mean anything. We all have to agree that it actually means this is our price list. We're getting strings here and strings here that represent product codes or SKUs or barcodes. Everyone has to agree that that's what they mean, and conversely that we're representing product codes using strings. So this is the primitive obsession thing again, and it's really easy to spot. The public interface mentions types that we didn't define.
So, in the spirit of leaving things for you to do at home, that's an exercise you can have a look at, is how you could refactor those out, and what connascence that might introduce further down. So
we've done a quick whistle-stop tour of 7 of the 9 kinds of connascence here, so we're just going to quickly rattle through what we've done, and then there'll be time for discussion.
So we started off by scanning a single item. We had our red failure. We got that to pass by just returning 50. And that left us with 4 types of connascence. Connascence of value, because both classes know the price. And connascence of execution order, because scanning doesn't have any effect on the balance. So that was where we had that empty scan method. And then also connascence of type and connascence of name, which we're going to leave in there. So we fixed that by introducing the constructor parameter. And that highlighted our connascence of meaning, but still left us with connascence of execution order as well. So we fixed this by writing a test for an empty checkout. We got that to pass by adding to the balance in our scan method. And then that left us with common setup of our checkout, which is connascence of algorithm. So we removed that by introducing our before block, which moved our checkout and the item price up into fields on our tests. Next, we've still got connascence of meaning which was where both classes knew that we were using an int to represent money. So we got rid of that by introducing our money class. That just left us with connaissance of type and connaissance of name again. So we added another test for different items with different prices. We got that to pass by just putting an if in our scan method. And by doing that, we introduced connaissance of value because everyone knows about the A SKU and everyone knows the price of B. We got connaissance of algorithm because we were doing balance.add in 2 places.
So the 2 branches of the if statement, they were different, but the code only worked because they were both doing balance.add.
And then we've got connaissance of meaning, where we were using strings to represent our SKUs. So to get rid of our connaissance of value, we introduced a parameter for the price of B. That introduced connaissance of position. So the connaissance of position where we had both the monies being passed into our constructor. So we've still got connaissance of value, which is our worst thing at this point, and our connaissance of algorithm and connaissance of meaning still from the last slide.
We've just beaten the world record for saying the word connaissance in an hour.
So we introduced a parameter to get rid of the connaissance of value for the item SKU, leaving us with connaissance of position, connaissance of algorithm, connaissance of meaning. We introduced a map to get rid of the connaissance of position to assign names to our prices, leaving us with just connaissance of meaning, connaissance of type. So, spoiler for everyone that's going to do this at home, we could introduce a price list to get rid of the connaissance of meaning for the map and a product code for the SKU. Okay.
So that was really quick tour of connaissance. There's an awful lot to take in, and an awful lot of what you've seen is still subjective because we could have gone down different routes at different times. But I hope you get a flavour of what connaissance can do for you to bypass some of the hand-wavy, oh look, there's duplication kind of stuff. So any questions? Yeah.
Where can I sort of find out more about this and some way of disseminating this knowledge, which I've just got to my sort of teammates and stuff?
The original writing on connaissance is about a page and a half in a terrible book about computer science. It languished there for about 10 years until Jim Weirich did some talks on it at Ruby conferences in 2004. The only other place where it's been written about very much is on my blog. The last 10 or so articles around Christmas time. I did the checkout kata again with different starting tests and therefore a different series of connaissance. There really isn't much written about this, which is kind of why we're doing the talking. So these slides are on SlideShare. Just look for me on SlideShare and you'll find these. But that's it really. We've got these that you can take away. There are laptop stickers here as well. But yeah, unfortunately, very few people are writing about this. Yeah.
Not so much a question, perhaps just to check my understanding. So insights into it. It struck me that for all but one of the connaissances, they lead you to do some refactoring to remove some duplication. Connaissance of value, you refactor to remove the duplication. Connaissance of meaning, slightly more interesting because the duplication is the meaning you resolve that by introducing a definition.
Yeah.
And then you get to connaissance of execution order,
Yeah.
which doesn't introduce a refactoring, it introduces a new test.
Well, that's the way I tackle it.
But it seems that, is there a duplication that you can identify that is connaissance of execution order, or is that the one that's different because it doesn't really represent duplication in the sense of repetition?
That's the problem with the word duplication. There's lots of different kinds. There's duplication of knowledge, of intention, of actual text in the code. And what you've got there with connaissance of execution order is duplication of knowledge about how the algorithm works and how it has to be called. And it seems to me that the simplest way of bringing that out is to write a failing test. So that's what I always do. If anybody comes up with an alternative, that would be great. I'd love to hear about it. I personally haven't found one. And writing that extra test kind of captures that knowledge in a real way.
It's just difficult to figure out exactly why, what makes that different. But another question for you is, have you thought about the transformation priority premise and their connection? They seem to be a kind of complementary, they're at different stages. This one is more about the refactor stage, transformation priority is what happens more during the green phase as you're writing the code. Is that something you've considered alongside this?
It is, and I prefer this. And I think because the transformation priority stuff feels less scientific.
Perhaps less practical. It's easier to say this, I think, how you can, not just for explaining to beginners how you go about doing this, but also for experienced people to actually apply it practically while working.
I would love for somebody to take the 9 kinds of connaissance and do for each of them a catalogue of the main kinds of refactoring you do. I mean, there isn't going to be a one-to-one mapping, you know, but there are definite tools and patterns that you can use with connaissance. The transformation priority stuff, I don't know, it doesn't feel as thorough somehow. I mean, this is still highly subjective. Yeah, this run through that we've just done is about the 7th we tried. You can do things in different orders. You can and initially we started with different starting tests, and we went off in a totally different direction. So we chose these starting tests because it allows us to show you 7 of the 9 kinds of connaissance. So and even then, the first few run-throughs, we missed some of the connaissance. We didn't spot it until later. So we're still learning how to do all this as well.
One problem that we have in a bunch of our antique and huge code base is we've got a whole bunch of types which are logically the same, but which have come by different routes. We've got probably half a dozen different classes representing a 3D position in space, represented in millimeters.
Mm-hmm.
So in a sense, each little chunk of code has developed their own types for their own API.
Yeah.
And the sort of code that I end up writing, which tends to be talking to this geometric modeler and getting them out of here and shoving them into there, seems to spend all its time translating between different but functionally equivalent little types.
Right.
Which again feels a different sort of duplication. I don't quite know.
Well, maybe it is, maybe it isn't. I mean, if this over here is one bounded context in domain-driven terms, and this is another bounded context in domain-driven terms. They've each got their own definition of a point in space that works for them, that works in that code.
Yeah.
Arguably, the only problem is that they're exposing those to you.
Yes.
So you've got connaissance of meaning in the sense that you and each of them have to agree with this one when you're talking to this one, and you have to agree with this one when you're talking to this one.
I need to know how to build one of these from one of those, and vice versa. And do
So
it fast.
another response to connaissance of meaning. So in every case here, we introduced a wrapper type. Another response is to introduce a wrapper layer to hide the API that mentions specific types behind something that mentions only types that you've defined. So you would write for each of the two things you're talking to, you might write an adapter layer that hides the details of them and is written from your point of view in terms that you've defined.
And the total volume of code is rising.
Well, not necessarily, because inside the body of your code, you would have your own representation of a 3D point, and you would have two thin adapter layers that convert that to and from the 3D point over here and 3D point over here. So in your code, you might have fewer places where you've got to do that check. So that's the basis of hexagonal architecture. You have anti-corruption layers around your code that protect it from the stuff coming in and going out to other parts of the world. So that's another approach to connaissance of meaning, is a kind of adapter layer, or facade, wrapper layer type of thing. That makes sense?
Thank you.
Anything else? Yeah.
Will you be releasing an IDE plugin?
I'm sorry?
Will you release an IDE plugin?
Well, that's the interesting thing, because the bottom view can be figured out through static analysis, but the top view can't. There's no way looking at code that you can figure out that this only works because it's pointing at the same thing that that's pointing at. So, yeah, the answer is tests. Anybody else? Stunned into silence. Okay, cool. Well, we'll have a slightly early finish then. Thanks for coming.
Thank you.
If you want to know any more about this, tap us up the rest of the conference. There are some kinesisometers here and some laptop stickers if you want them. Thank you. Thank you.
Kevin, do you want to drink water?
Yeah, that's good.
Get you a glass.
I'll just...
The kinesisometers as well also have our blog addresses on, if anyone wants them.
That was really, really good.